Hey everyone, we're going to go ahead and go over polynomial functions. This lesson was split into 2 days, so I'm going to actually make 2 different videos. So this is going to be part 1. And I am going to express with this. I am recording this during school, so there will be some bells going off as usual. So don't be too surprised on those. But we're going to go ahead and get started. The focus of this is more just to make sure that my students that miss class, you have something to look at, or for those that maybe we went a little too fast, we didn't get to certain things I wanted to, that we do actually get a chance to cover it. So starting off with the definition of a polynomial function, it is a function in the form that is given here, a sub x, a to the n, or I'm sorry, a sub n, x to the n plus a sub n minus 1 to the xn minus 1, and so forth, until you get to the point where you get to x squared, x, and your constant. The goal here is that all your coefficients are real numbers. All exponents are whole numbers, meaning we have no fractions, no decimals in our exponent section. And that the leading coefficient, which is at the start, this a sub n right here, this cannot be equal to 0. This here cannot be equal to 0 is what they're referring to. And that all our exponents are positive integers. So basically, again, making sure they're all nothing having a fraction in here. As a reminder, the degree of a polynomial function is the value of the greatest exponent. So we're always looking to see what the highest exponent is for us to tell us what we need to know about functions. So here we have a polynomial parent function where the constant is 0. So that would be basically my y equals 0 or y equals x. Not y equals x, but like y equals the constant. So, but we're going to use f of x because we're talking about functions. So f of x equals a number. So that would just give me a flat line. It's a horizontal line. Then for degree 1, which would be f of x equals x, would be our parent function is a linear. Quadratic, x squared, which gets us a parabola. The shape of it tells us so much about it. So again, one of the most important things we can stress is make sure you're drawing these arrows, because they are going to be something we've referenced later on. And do notice some patterns that will emerge. And as always, pause the video if you need more time. Our next set of parent functions is going to be cubic. So x to the third kind of looks like a sideways S. Quartic. This is just going to look more like a narrow quadratic.
Beginning the second period.
All right, and then we have f of x equals x to the fifth for a quintic, and this is going to be a more narrow cubic function. So with these, they look more narrow mainly because they are growing faster. So like if I looked at my y values for x to the fourth, it goes from 0 to 1 to 16 to 81 to 625 and so on. So those are the first y values for when x is 0, 1, 2, 3, 4, 5, which is growing much faster than it is the quadratic, which is growing by perfect squares. And the same thing with our quintic. It's just growing so much faster, so it's more narrow. And this is easier to see if I had all of them on the same slide. But do you notice that all of our odd functions have arrows going in both directions?
Teachers, please close your doors at this time. Any students not already in the classroom must report to the nearest party station to receive a pass to class.
And notice that the even functions have arrows pointing both the same way. So if you're not sure when we're looking at it, something we're going to ask about you is the function even and odd. One of the ways we're going to know that is literally by looking at the arrows. And if you have a pair going the same direction, it's an even, and that's easy to remember because all pairs are 2 with 2 is even. You can tell they're odd because you have 1 in each direction, so it's an odd pair. But that is something that we're going to come talk about as we go through these lessons. At turning points, the point at which all a polynomial function switches directions. Nothing crazy, but they are very significant for us specifically in math. So starting off, if the point is higher, or I should express this, we have 2 turning points. We have our green dot and our purple dot, because again, they are changing directions. If the turning point is higher, like in our green dot, it is called a relative maximum. If the turning point is lower than any nearby point, it is called a relative minimum. So those, they do have some, again, this is where a lot of the things for our higher math classes, we do want to look at that. Turning point's very important for us. The max and min values are called extrema. So sometimes when they want to say they want you to find both, mins and maxes, they're going to use the word extrema just to use less words. Turning points define where a function is increasing or decreasing. So these turning points is if we're looking at this. So as we look and we say when it happened or where it happens, we're looking at our x values from when does this happen? When is the slope positive? When is the slope negative? So for this first section, as we can see, the graph is going up as we read left to right. That is always, remember, it's as we read left to right, because that is how we read. So what has happened for us? Time on a number line goes from negative positive from left to right. We can see in that first section before that turning point, the slope is positive. The graph is increasing. We can see that this middle section, the graph is decreasing. And then in the third section, we can see that it is increasing yet again. But that's something we will be looking at. And always that, again, it tells us so much more about the graph than we go into as too far in depth in this class. We go into it more in depth in pre-calc calculus. So how to find turning points? There's a couple different ways to do these. This set of directions is for if you were in the classroom and using the TI Inspire, which is you would graph the function, press menu 6, choose min or max, place the dash line before and after. But again, that would be more for if you are using the school calculator. If you're using Desmos, a lot of this stuff is already turned on for you. So for the sake of this lesson, I am going to go ahead and use Desmos just because it looks so much nicer on the screen and I have much more control over it. I will demo though for you to see what I mean by the dash line before and the dash line after. So let me go ahead and pull that up. So we're going to go ahead. So we have Desmos graphing is one of the things we want. I do want to go to Clever so I can pull up the school calculator so I can show you what we're talking about when we say that before after portion. I had Clever as a link. All right, so we'll just do it this way. All right, sorry for that. So I'm gonna go ahead and show it to you on Desmos first. So that when we're looking at it, so just make sure I have the correct equation. We're gonna go back to that PowerPoint. So x cubed minus 6x plus 7x plus 2. So x cubed, 6x squared plus 7x. All right, so we have x cubed minus 6x squared plus 7x plus 2. I'm just going to double. I feel like that's wrong because I feel maybe it is right. Let's see. Minus 6x squared plus 7x plus 2. All right, so that is correct. So here's a graph, and when you're doing this on Desmos, I'm going to change this to presenter mode essentially. That when I click on it, we can see that it marks so many places for me automatically. We're also going to take a look though. One of the things, if you need help, go ahead and pull the table by using the gear. But using the school calculator, just so that some of you would have an example to see this. I create a new document. We're going to add a graph. We do like to make sure that we're practicing using documents always. So we're going to do X, and we're going to press this caret top. On your keyboard, it is Shift-6. On the calculator, you're just going to press the caret top button here. Press 3, get out of the exponent. Minus 6x squared plus 7x plus 2. So here's the same graph. I'm going to move this over so we can see that. So we said menu 6, and we're always going to look and see which one we're looking at. So the first one is a maximum, so I'm going to start with the max. So here's my dashed line. So when we say put it before, just put it a little before that turning point, and you're going to slide it over, and you're going to click so it's past it. So here is my turning point. When you're using the calculator in person, though, you can use the touchpad up here. And you can also press down on this for when you want to put your the start and end points. So here is my maximum. And then here we're going to do it again, menu 6-2. We're going to take that dashed line, press enter, scroll it over, press enter. So these are my 2 turning points. Which if I look here, with rounding, it's about the same. So we are going to go ahead and do 7.09 or 0.709 and 4.3, and then 3.29 with negative 4.3. So it just the amount you use depends on what we're using. Typically, we'll say 2 to 3 decimal points. We'll be a bit more specific. But since I was using the directions we're using specifically the school calculator, we will use the rounding that's on here. So as we can see in that first section, I go over here. As we can see in this first section right here, we can see that the slope is positive, and then the slope is negative, slope is positive. So when we're looking at this, my slope is increasing from at the start of my graph, which is at negative infinity, until we get to this first turning point at 0.709, and then it's decreasing from 7.09 to 3.29, and then from 3.29 to infinity, because that's where the graph ends, it is increasing. So that's how I would fill this out on my notes. Moving on to our next problem. So we're going to graph each polynomial function using a table, then given the domain, range, increasing, decreasing intervals, and behavior. So looking at number 1, we're going to go ahead and graph these. If you want, we'll probably go ahead and use Desmos just because so that on the screen it just looks a bit easier for me to show you guys the information. But we're going to go ahead, go into Desmos. So we're going to clear this. So we're going to have x cubed minus 3x squared minus 3. So here's my graph. This is if you can move it as needed. If you're using the notes handout, I would use any x value or x and y values that have the y values living between -10 and 10, mainly because that's just the area I've given you on your graph. So I would plot the points from -1 to 3. And here I can click here for my turning points, which is very nice. So that tells us quite a bit. So going back to this, we're going to go ahead and put this on our graph and answer all the questions. So we're gonna go ahead, plot these points. All right, so first thing we do is plot our points. So -1 down to -7. 1, 2, 3, 4, 5, 6, 7. 0, -3, 1, 2, 3. -5, -7, -3, and then 13 is outside my range. So again, when we're drawing these, they should look curve-like. So when we're looking here, I can see I have arrows going both directions. I will let you know all domains are all real numbers for this topic. Doesn't matter on the function. For this topic, all domain is all real numbers. Our range, because it is an odd function, is actually also going to be all real numbers. And using the graph, we found that our turning point here is at 0, -3, and then the turning point here is at -2, -7. So my relative max is going to be at 0, -3, my minimum at -2, -7. So when we're looking at this, I can see that it's increasing from this first section and this last section. So it starts at -infinity, and at 0, it stops increasing. And from 0 to -2, which is my next turning point, it is decreasing. And from there, from -2 to infinity, it is increasing yet again. We are actually always using the x values of my turning points for me to figure out where it is happening. So that is where I got those. Next, for end behavior, this is read as the graph goes left. What is y doing? That's what this says. So as x approaches -infinity, f of x approaches. So what we're looking at is this arrow here. I can see it's pointing down, so it goes towards -infinity. The next line reads, as the graph goes right, f of x goes. So as we go to +infinity for x, the y values go up forever, so that goes to +infinity. As always, pause the video as needed. Moving on to our next question. So I'm going to go ahead and do question 2 together. So we're going to go ahead and graph that. There it is. So we have x to the 4th plus x cubed minus 4x squared plus 5. So I'm going to move so I can see it as needed. So it looks like a lopsided W. So here are our turning points. Here are -2 here. So we're going to go ahead and plot those points. My turning points, we're going to go ahead and find those. All right, so let's go ahead and put that information on our screen. So we graphed this, and then we're going to go ahead and so we're going to start off by graphing it over here. -2, -3, -1, 1, 0, 5, 1, 2, 3, 4, 5, 3. That's as best as I can get. Knowing it looks like a W. Oops. No, it doesn't have to be exact. It should look about what it's supposed to look like. But there are a couple of things that we want to go ahead and look at. We're going to go ahead and write down our relative min and maxes since we just needed to click those. We have one max at 0, 5. So this here is a max. This is a min. This is a min. So we have two minimums. -1.8. We're going to go to two decimal places. -3.31. And then our other coordinate point is 1.0. We're going to round to two decimal places. 9, 2.95. So those are our turning points. As I said earlier, our domain is going to be all real numbers. Since this is an even function, and I can tell that based on my arrows, we do have a limited range. So like my range goes from here all the way up forever. Probably should have used a thinner highlighter to talk about that. So we're going to say the range is from here all the way up. So we take the absolute minimum, which is at, remember it's our y values, as we might know, y for range, x for domain. So it starts at, and it exists there at -3.31, and then goes on forever to infinity. Now, when we look at our increasing, decreasing, we can see that it is decreasing first, and then increasing, and then decreasing again, and then increasing again. So the yellows are decreasing slopes. So we're going to start with those. So that starts at -infinity because that's at the start. And my first turning point is at -1.84. From -1.84, it is increasing until we get to 0. So from 0 until my next turning point at 1.09. It is decreasing, but from 1.09 to infinity, it is increasing. All right, my end behavior. Again, this first one is to the left, bottom one's to the right. We're just looking at the arrow. So here's my right arrow and my left arrow. They're both pointing up, so they're both going to infinity. Again, as always, pause the video as needed. For the next three problems, for those that actually have the handout in front of them, they are going to be you try, so I want you to go ahead and try those on your own. So I'm going to give you a moment to I'm going to go to the next slide for those that are trying to do this on their own without the handout. So go ahead, try this problem, see if you can identify domain, range, min, max, increasing, decreasing, and behaviors while trying to graph your function, and then we will go over it in a moment. So go ahead, pause the video, give this a shot. All right, let's go ahead and check your work. So here we do have our graph. The only thing I don't have on these are my arrows. Again, as I said, domain, all real numbers. Because range, since they're going, I have arrows in both directions. It is all real numbers. We have a max here because it is the highest point. This is a min. So our max is at 2, 4. Our minimum's at 0, 0. The graph starts as decreasing, so it decreases twice, and it increases at one time. So it starts at decreasing from -infinity to 0, and then from 0 to 2, it's increasing, and then from 2 to infinity, it is decreasing again. As we go to the left, the arrow is pointing up. As we go to the right, the arrow is pointing down. So as x approaches negative infinity, f of x approaches positive infinity. As x approaches positive infinity, f of x approaches negative infinity is my behavior. Let's take a look at our next one. So pause the video. I want you to go ahead and try this problem. Especially, I do want you to focus on the range, because this one will not be all real numbers. So I do want you to pause the video, give this one a shot. All right, let's go ahead and check your work. So again, as I said, domain's all real numbers. And this is where we start with our rounding. Might be an issue for some of us to make sure we're doing our rounding correctly. I did say round to 2 decimal places, so that is what we're going to use. So first off, it should look like a lopsided M. Domain all real numbers, our range. We do have a max, so we have a high point. So we're going to use that Y value for my maximum. So we're going to say 6.5. I really should have 6.50, but we're going to go with 6.5. And then we have a minimum here, and we have another maximum up here. So we have 2 maxes and 2 mins. So my range goes from negative infinity, because that's where it starts, my lowest Y value, up until 6.5. My maximums are at negative 1.57 and at 1.16, comma, negative 1.91. Our minimum is at 0, it's not at 0.2, it's at here we are. So our minimum here is at 0.41, comma, negative 0.2 or negative 2.59. Yeah. I'm looking at the numbers in the screen, trying to make connecting them. So again, we go ahead and take a look at our increasing. So we start with increasing, and then decrease, increase, and then decrease. You should always be alternating between the two. So increasing starts at negative infinity to negative 1.57. We then decrease from negative 1.57 to 0.41. Which then means we increase from 0.41 to 1.116, and 1.116 to infinity, we are increasing. My end behavior are both pointing down. So negative infinity, negative infinity. And for our last problem for this part of the lesson, go ahead and try number 5, 2x cubed minus 4x squared minus x. All right, let's go ahead and check your work. So here is our graph. Domains all real numbers, ranges all real numbers. We have 2 turning points. We have a maximum at negative 0.12, comma 0.6. And then we have a minimum at 1.45, comma negative 3.76. Our graph goes increasing, decreasing, increasing. As I put my arrows in. And we do have our end behavior right here. So our increasing from negative infinity to negative 0.12 to, and then from negative 0.12 to 1.45, we are decreasing, and then 1.45 to infinity, we are increasing. My end behavior as we go to the left is towards negative infinity, and as we go to the right to positive infinity. So that is where we're going to finish off for that part. So I'm going to go ahead and end this video, and I will see you in part 2.